What are macrostates? Statistical Mechanics Basics. Have you ever wondered how scientists describe the behavior of large groups of particles? Today, we will break down the concept of macrostates in a way that is easy to grasp. A macrostate is essentially a way to characterize a thermodynamic system based on its large-scale properties. These properties include temperature, pressure, volume, and internal energy. They give us a snapshot of the system's overall condition that we can measure or control during experiments. Now, let's contrast this with the idea of microstates. A microstate refers to the specific arrangement of every single particle in the system. This means knowing the exact position and momentum of each atom or molecule. While there are countless microstates possible, many of them can correspond to the same macrostate. This is because they share the same overall measurable properties. The fascinating part is that a single macrostate can be linked to numerous microstates. The number of microstates that fit a given macrostate is known as multiplicity. This concept plays a vital role in statistical mechanics, which connects the tiny world of particles to the larger properties we can observe. Now, let's talk about entropy. This is a key idea in thermodynamics and is closely related to macrostates. The more microstates available to a macrostate, the higher its entropy. This means that the system is more disordered and has more ways to arrange itself while keeping the same overall properties. Understanding macrostates also helps explain why certain processes occur spontaneously. For example, heat naturally flows from hot to cold. This happens because systems tend to move toward macrostates with higher entropy. These higher entropy states correspond to a larger number of microstates, making them more likely to occur. In essence, macrostates offer a simplified yet powerful way to describe complex systems by focusing on observable properties. Statistical mechanics then explains these macrostates in terms of the many underlying microstates. This connection makes the principles of thermodynamics more approachable and relevant to our everyday experiences.